Hi students, today in this session we are going to study the last topic of this chapter, and that is a comparison of basic strengths of pyrrole, pyridine and piperidine. This is also, as you know, this is one of the very important question that is asked in your exam. Okay, so if they ask all three comparatives, all comparison of basic strength of all these three compounds together, then they will ask for 4 marks. Either they will ask the questions like the basic strength of pyrrole and pyridine, or the compare basic strength of pyridine and piperidine. Then it may also ask for 2 marks. So it is one of the very many times it has been asked in your exams. So one of the very important topic. That's why we'll see it. Okay. So first we should know about the acidic, what is basic nature. The one basic nature according to Bronsted-Lowry's theories, the one has to accept the proton. It has to undergo protonation. So in that, on the base of that theory also we'll discuss the basic strength. And also another theory here, you can all see there they have a lone pair of electrons and over in nitrogen atom, hence we can also give the basic strength on the basis of Levy's theory. So the pair of electrons donators, the donors, electron pair donors are Levy bases, and those which accept the protons are Bronsted bases. Both theories will apply, and we'll see the basic strength of these three compounds, which is more basic, which is less basic. Yes. Now first I will discuss how they will react with the protons when they undergo protonation. First discuss the what is that is Bronsted theory. I'll discuss there. Yeah. First compound, if you take pyrrole, pyrrole is a 5-membered heterocyclic aromatic compound. Yes. So in the case of pyrrole, when we add an acid like HCl, okay, if it is able to accept this proton, so it is going to form N double bond plus H and HCl. Yes, okay. Base and acid, when the base and acid react, they form salt. So when pyrrole undergo protonation, so it is going to form pyrrole HCl, right? Hydrochloride. Pyrrole hydrochloride. Yes, the one thing you should know here, so here these electrons are involving in aromatic. So they are forming the aromatic sextet. They are delocalizing electrons inside the ring. But if you see here, those electrons have gone because the proton has been accepted by the nitrogen. Hence here there are 6 pi electrons, here only 4 pi electrons. Hence it lost aromaticity. There is a loss of aromaticity. It lose aromaticity. As you know, aromatic compounds are more stable compound. So if it is able to lose this aromaticity, this compound will become unstable. This compound will become unstable. If it is giving an unstable salt, that reaction does not possible and does not undergo. So then hence this pyrrole cannot undergo protonation. So it cannot accept that proton, because if it accepts this proton, it will lose its aromaticity. Hence it is not a so good Bronsted base. If you talk about electrons, so these lone pair of electrons are not available because they are involving in the delocalization. So if it is not able to donate that pair of electrons. It is also not a good Levy space. It is not a base especially. So it is one of the very weak base. Hence it becomes very weak base. Okay. Now the same thing will apply for the pyridine. So when we take pyridine, pyridine is a pyridine. So that is 5-membered. It is a 6-membered heterocyclic ring. So in case pyridine, when it is reacted with the acid like hydrochloride as a hydrochloric acid, so this also accept that proton. Yeah, that H has been come here, and it is compensated with the positive charge is compensated with negative charge. So it is going to give pyridinium hydrochloride. Pyridinium hydrochloride, which is one of the stable, because here we do not lose any aromaticity. The aromaticity is retained. There is no disturbance, no disturbance in disturbance, no disturbance in aromaticity. So it still retain that aromaticity. Hence, this is stable one. This is a stable one compared to pyrrole. So pyrrole gives an unstable salt, but pyridine can give stable salt. So stable salt. Okay, sorry. So here if you see, it can easily accept that proton, hence it is a good Bronsted base. And these lone pair of electron do not involve in the aromaticity, or it is not, they are not delocalizing. They are very much free in the sp2 hybrid orbitals, so they are available, easily available for this proton. So hence this nitrogen or this pyridine whole compound can donate this lone pair of electrons. Hence it is also one of the good Lewis base. Okay, this is a good or base. It is a good base, stronger one compared to this which one, pyrrole and pyridine. So hence pyridine is the stronger base compared to pyrrole. So now I can put a symbol. Pyridine is weaker in basic strength compared to the pyridine. Sorry, pyrrole is less basic compared to pyridine. So now we'll see another compound, that is piperidine or piperidine. See here. So this piperidine or piperidine is also a 6-membered heterocyclic ring, but it is aliphatic in nature. It is aliphatic. It is not aromatic. So it is aliphatic one, piperidine. Yeah. So when it is treated with an acid like HCl, it easily undergo that protonation like a secondary amine. It is actually a secondary amine. Yeah. Piperidine, here Cl minus. So it is going to give piperidine hydrochloride. Pyridine hydrochloride. Yeah. So here also same protonation is possible. Here also protonation is possible. So hence these are good bases. Okay. The good Bronsted bases which accept easily the proton. Yes, of course. But the one thing here, it is a lesser Lewis base compared to here in the case of piperidine, because the one thing, these lone pairs, though they are not involving in aromaticity, but they are involved by that is influenced by that aromaticity. So that's why. And also one more thing, this nitrogen is sp2 hybridized, of course, but here it is sp3 hybridized, sp3 hybridized, so like secondary amine. So you please remember, the nitrogen in sp2 hybridized, nitrogen in sp2 hybridized is more electronegative, is more electronegative than the nitrogen in sp3 hybridized. You please remember this one. The nitrogen in sp2 hybridized is more electronegative than the nitrogen in sp3 hybridized. Yes, here you see here, this is sp2 hybridized, this is sp3 hybridized. So these electrons are in sp2 hybrid orbitals, these are in sp3 hybrid orbitals. So as it is more electronegative, what is electronegativity? Electronegativity is the acceptance or attracting the electrons, not giving electrons, so hence the rate of donation of these electrons or rate of providing these electrons or the availability of these electrons, the rate of availability of these pair of electrons is less compared to the rate of availability of the electrons in the piperidine. You got this? These electrons are available, these are also available, but these are very much available and easily can give it to the other orbitals, but these electrons are not possible. Hence, this is a weaker Lewis space, it is a stronger Lewis space. It is a weaker base, it is a stronger base. So this piperidine become a very stronger base, strong base. Now, can I put the simple? So, pyrrole is less basic than pyridine and pyridine is less basic than piperidine. Please remember this one. Okay? Yeah. And it is also yes, it is also confirmed by their pKb values. You know, the one which has a more pKb value, that is more basic. So if you consider the pKb value of, I'll write here, the pKb value of pyrrole is just around 3.4. And if you consider the pKb value of pyridine, this is about 5.2. This is about 5.2. And if you see the pKb value of piperidine, it is about 11.2. See the value? This is the more stronger base. So that also you should remember. More the value of pKb, that means more is basic, more or high basic. Okay, so the pKb value of pyrrole is 3.4, pKb value of pyridine is 5.2, the pKb value of piperidine is about 11.2. So that is having a higher value, hence it is the more, and compared to here it is the most basic, it is more basic, it is less basic. Okay, so now in this method we can express the basic strength and we can compare the basic strength in three manners. One is about according to Bronsted theory, means when they accept the proton. So here when it pyrrole accept the proton, it gives pyrrole hydrochloride, which is unstable because it loses its aromaticity. These electrons should be involved in the delocalization. When they accept the proton, those electrons will come out of the aromatic ring. So hence this is not possible. Hence the pyrrole become the most least basic. And here in the case of pyridine, these electrons are easily available, and the Bronsted, right? This can easily accept that hydrogen proton, and it can form a stable pyridinium hydrochloride. So here also it is very easier, like it is a secondary amine. It can easily take that proton and form a stable, one of the more stable piperidine hydrochloride salt. Okay, this is about Bronsted theory. Okay, these are good Bronsted as bases. This is not a good Bronsted base. It is also not good Lewis base, because these pair of electrons are not available at all. According to Bronsted theory, Lewis theory, the Lewis base has to donate pair of electrons. These electrons are not at all available, hence it will become a very least basic. Here, yes, these electrons are available, these electrons are also available, but the nitrogen in the pyridine is sp2 hybridized, but the nitrogen in the piperidine is sp3 hybridized. We have one for rule, that is the any element that is especially electronegative element in sp2 hybridized is more electronegative than sp3. So nitrogen is more electronegative in the case of pyridine, that is less in the case of piperidine. So electronegativity means they have to accept electrons, not to donate electrons. So it, as the electronegativity value of nitrogen in pyridine is more, which is not easier to donate this pair of electrons. But here the electronegative value of nitrogen in piperidine is less, which is easier to donate that lone pair of electrons. So this is about the electron theory and also the Bronsted. These two theories, which one? Bronsted and also Lewis. So this is not a good Bronsted base and also not good Lewis base. This is a good Bronsted base but not a good Lewis base. This is a very good Bronsted base and also very good Lewis base. Hence this become the most basic. This is piperidine, and pyrrole become a least basic, and the pyridine have the moderate value of basic strength. And it is also confirmed by their pKb value, as already you've seen. So among these three concepts, one is Bronsted, another one is Lewis, and also confirmation by their pKb values, we can determine the basic strength, and we can easily compare the basic strength among these three compounds. Yes, this is about the basic strength of these compounds. And thank you. This is the last topic in this chapter. I have been selected, the heterocyclic compounds. Please do watch all the videos, and please like all the videos and watch them completely. Then you'll get the whole chapter and the idea of the whole chapter. And please like my videos and keep in touch. Keep watching. So we will get also updates of the new chapter that I'm going to uploading from the next days. Thank you. Thank you for all your support.